Can you see my screens now?
Yes.
Perfect.
Thank you.
So yeah, a little about myself. Like I was saying, being a woman in IT hasn't, has been a great journey for myself as well. It hasn't been a simple one, but it's definitely been an exciting one. And one thing I can definitely say, it's the place to be. And if that's something, and what we're trying to do with these courses as well is just to educate, just to sort of like get out the information that I obviously never went through. When I was at university, I didn't really have much insight into virtualization, didn't know much about cloud. So it's everything I've learned is on the job itself. So, when I was given the opportunity to sort of present this back to the outside world, it just felt like, this is a great opportunity to sort of introduce these topics which aren't readily available. And it's a great opportunity for you guys to sort of get your badges involved as well. So if I was to quickly show you the screen, and this is where you've got the code there as well, which you can scan and sort of log into the site itself, or you can Google VMITA NDG to access the website, which can actually help you enroll into the platform. And I can talk you. Let me just quickly stop sharing, and I'll walk you through the entire process. That way, you can see how what the place will look like. So let me just share my screen again now. So when you access the page, you will see something like this. And from here, you'd want to, so once you type that into Google, the first link that comes up, when you type in VMITA NDG, the first link that would come up, it would be this particular platform. So you're going to click on Cloud Virtualization Concept, because that's the first of the 3 series that we're going to be going through today. And once you click through that, it should hopefully take you to the registration page that you saw earlier. Now, when you do enter your full name, your email address, it's going to send you a verification key. So it has done that. So like you can see here, I have verified my email address. So I can now complete the enrollment and kind of be logged in. And basically, this is what you'll get. So on the left-hand side, you'll have all your labs. So essentially, it's got all the content that you would possibly need in order to sort of understand the concepts that we're going through today. So, we're talking about our different virtualization concepts. We're talking about how to connect the storage, how to connect the network, and all those concepts. You can actually then see it live when you go through these separate modules in this platform. And the beauty of that is you can actually have a more hands-on effect with it. So you can actually do some work around virtualization itself, like create your own virtual machines, attach storage, attach network, just so something you can get involved in as from where you go. So it just puts a lot of it into practice. And from there on, you can go ahead and then collect your badge as well from the end of this. And it should usually doesn't take that long, but it should load up. And then yeah, here you can see you can go through your entire content. So if you click on the content, it'll take you through the entire module, which you can then work on in the lab itself. So without further ado, let's walk right into the content itself. So let me just quickly share my screen again. So let's talk about virtualization, right? And why even learn virtualization? Well, virtualization industry has grown significantly over the last, I would say, 5-10 years, especially. There's constantly something evolving around this. There's always something new. There's new concepts, there's new changes. But the beauty of virtualization is the fact that it's all around us at this very moment in time. I mean, we're all involved with virtualization in one way or the other. So it's a great place to sort of to be and to sort of learn more about, because even from a personal perspective or career perspective, it's a great opportunity to get to know what's really happening when we talk about modern computing, because it's all around virtualization. So when you talk about all these newer computing concepts when you talk about containers, when you're talking about, applications. All of these revolve around this very simple concept of virtualization. So today we're just going to be talking about that. So today's content will cover just understanding the benefits of virtualization. We'll be talking about, we'll describe what virtualization really means, what virtual machines are, what hypervisors do. We're going to talk you through typical data center components, what it means for them to be virtualized, what does it mean for organizations. And then I'll talk you through our VMware technology and, why it's so popular in the industry and why it's the market leader in virtualization. So first things first, let's talk about, the benefits of virtualization. Now, have you ever personally wished that you could clone yourself? Like if, say you had a requirement to be, watching Netflix 1 minute, but you were required to clean the house, at the same time. I mean, it would be great if we could do that. That would be just amazing had we been able to do that, because that would just make us so much more efficient, right? We could do multiple things at the same time. Now, virtualization actually allows that to happen for computers, because like us, computers can only do one thing at a time, especially those big mainframe computers. So we'll go into that a bit later on. Essentially getting them to be virtualized and allowing them to do multiple things at a single time allows them to be that much more optimized, so they can actually do a lot more, be a lot more efficient in their time and how they're used. So moving on to actually mentioning what virtualization really is, I've got a definition here and I'm just going to quickly read that out to you. So virtualization uses software to create an abstraction layer over computer hardware that allows the hardware element of a single computer to be divided into multiple virtual components. Makes much sense? I don't think so. It's a bunch of words, and really, what does it really mean by virtualization? But the two words that really jump out, and I'll explain the definition as we go along, is software and hardware. Those are the two key components that really jump out from this particular definition. So let's see what we mean by hardware and software. Now, we all use smartphones, we're using laptops, we're using computer devices, we've got iPads, we've got smartwatches. All of these things and all of these devices are simply different forms of hardware, right? But then all these devices would mean nothing to us, and they wouldn't really have much, use to us if we didn't have any software, right? And essentially, it's very similar to how our brains work for us as humans. Without our brains, we're nothing, right? It's what really gives us all the functions to do. It gives us the reasoning to do something. Software is the brain for the hardware, and what gives hardware its life, right? So without software, hardware might as well be nothing. So when we're talking about software, we're not just talking about just one particular software that's running. We're talking about different types of software that really control all of the computer actions that happen. So everything that we do on a computer, on a hardware device, is controlled by a software. So let's just take a deeper look into understanding some of the common components of a hardware. So first of all, we have a processor, which, also known as a central processing unit or a CPU. Now, this handles all the, the basic systems instructions, such as, processing mouse or a keyboard, or, running an application. It most likely can be argued that it's one of the most crucial parts of of running an application, because its processor is that part of a computer that really interprets all the commands that a user is making and then really performs them as requested. So it's the one that's taking the action. Now, then we have this thing called RAM, or random access memory. Now, random access memory is computer's version of a short-term memory, and none of your programs, like your files or any Netflix streaming and any of that, would really work if you didn't have a good enough RAM. And what RAM basically is, it's that temporary storage that goes away as soon as you turn off your computer. So you can think of RAM like as your physical desktop, right? Your working space. So, if you were to scribble something immediately, it'd be on the top of the desk. You'll want it to be readily available so you can quickly go back to it and use it. So, you'd want it in the arm's length. You wanted something that you can quickly reach out to and get it. And you don't want any delay in finding that information, which is why, you've written it on your desk and you've left it there. Now, RAM's pretty much like that. And in contrast to that, if you wanted to keep any of your work for later on, and if you really wanted to store something, you'd put it in a desk drawer. Now, that's very much like a hard disk or a hard drive, which we'll go on to later on as well. Then we have ROM, which is your read-only memory. Now, that refers to computers' memory chips, they're containing the permanent data. So unlike RAM, ROM is a non-volatile. So, even after you turn off your computer, the content that's within the ROM will remain. So every computer comes, with a small amount of ROM. So it's what contains the boot firmware. So, it has all those, a few kilobyte of code, which actually instructs your computer what to do when it starts up. So, running any hardware diagnostics or loading and, the operating system as soon as you start up into the RAM. So that's all of that coding is stored inside ROM, which is your read-only memory, something that you can't change or, write over. Then you have motherboard. So we've heard, motherboards, you can call them MBs. I've heard them be called main boards, or if you're using Apple computers, then it's a logic board. But the main idea behind a motherboard is it's a printed circuit board, right? And the foundation of a computer. And it's the biggest board in a computer chassis. So what it really does, it allocates power and it allows communication between all these different components. So between CPU and RAM and all the different, hardware components, it goes through this motherboard. So it's that communication piece that sits inside the computer chassis. And then you have storage. You have chipsets, which of micro chipsets on the motherboard that really manage specific functions, around data flow between different processes and memory and peripherals. And then we move on to storage, which is your persistent storage and devices such as your hard drive, your HDDs, or your SSD, which is your solid state drive. And we'll go into that in a little bit more detailed as we go ahead with the presentation. So now moving on to software. As we've already sort of established, software is super important for hardware to function, right? It's the operating system inside our computers that actually allows us to do anything, because without it, we might as well just have it as a paperweight. And application software really tells our system, and it's basically instructions that you give to your computer to do tasks. So that's why software is super important in the back end. So now if I was to tell you what virtualization is, so now that you understand the roles of how hardware works and how software comes into play, the concept of virtualization should be much more easy to grasp, which is it's basically a layer of technology that goes between the physical hardware of a device and the operating system, which is the software, to create one or more copies of that same device. So you can have one computer doing the job of many computers. And to you, you might think, hey, why would I even want that? Why would I need one computer doing jobs of many other, many computers? So if I was to ask you to imagine having an iPhone that can only launch, say, one application, so you can only call someone, or you can only access Instagram, or you need to have a separate phone for accessing WhatsApp. That could prove to be super expensive when it comes to it, because if you think about it, you'll need all these different devices to access different applications. Now imagine organizations who are running the back end of these applications in their data centers. Imagine how expensive this could be for them. Now I've mentioned data centers. So before I go into explaining the benefits of virtualization to organization and what it's done for these big organizations, let's talk a little about what we mean by data centers and what they really are. Now, at its very simplest, a data center is simply a physical facility, right? It could be a building or a room or a room in a building. It could be an entire building. It could be a really big place. It could be a small place. Essentially, a data center is where organizations tend to house all their computer systems and all the hardware that goes with it. So in order to process any of their applications, they need to have these data centers on premises. So that's where they'll be running all their applications, all their critical data will be sitting inside these data centers. And data centers have three main components. It's compute, there's storage, and there's network. It's these three things that enables the delivery of all those shared applications and the shared data that an organization needs in order to run the IT infrastructure. So if we quickly go into talking about what these three different components are of a data center, so the first one being compute. Now, this is a server hardware. You can generally define like a physical server as a typical computer, right? While they're much larger than what you think, when you imagine a desktop computer, but the way they function is quite in the same way, but on a business scale, like it's a much larger than business scale grade kind of a thing. So, physical servers are much more powerful. There are more powerful computers that run operating systems and applications for all their internal hardware resources. And what really makes servers different from PCs is, well, when we're using our PCs, we have this really friendly interface where we can, run our applications. We have a decent interface that can listen to us, and we can perform actions using this interface. However, a job of a server is primarily to focus on running, these programs that are essentially generating these applications in the back end. Now, there are three key types of servers. So the first one being your tower, and this one's a very simple one. They look very similar to your desktop PCs, and most people tend to have them in their own home labs. Then you have racks, and these are sort of designed to accommodate multiple servers. They're specifically constructed to fit into really small spaces. So if you're thinking of a data center, you can imagine racks against racks, and they'll all have all these servers stacked, right on top of one another. Now, having one server right on top of the other and racking them upwards could be disastrous when it comes to thinking about how you would cool them, because cooling these devices could prove to be really difficult. But on the plus point, when it comes to scalability, it's really easy because they can quickly put up another server on top of the rack, and you can just build it up that way. And then you have blade servers. And these are very similar to rack servers in design, but what they are is that they're much thinner, and they also cost a lot more than the rack servers. And a blade server is basically a modular component that really fits into the server chassis along with all the other blades. So each blade would have its own processor, its own memory, and an integrated network connected to it. So these could then be planted into a rack. So these are the three key types of servers that you'd find in most data centers. Moving on to just the second component of a data center, which is basically networks, right? Now, networks in general are super important, but in the data center world, they're even more so, because network is what's responsible for interconnecting the entire physical and network-based devices and equipments within the entire data center facility. So essentially, it's what allows that digital connection between the data center infrastructure and the equipment, so that they can communicate and transfer data between each other over the internet. So some different types of hardware that you'd be using for networking would be, we'll have networking switches, you'll have routers, you'll have firewalls, as well as plenty of cabling. All of these cables that you see on scary data center images, they do exist, and those are actually super important for it then, being able to connect everything together. So they really help connect with both everything internally and with the external world, which is through internet. And then the final component within the data center, we have storage. Now, obviously, storage is very important for any organization. And one key feature that we tend to see when it comes to data center storage is availability. Data within the data center needs to be readily available at all times. And any unavailability of data can actually cause significant loss for an organization. And the second feature that is quite important when it comes to data center storage is redundancy, right? Because if something was to happen to a company's data, such as there was a disk failure, or a server went down, that would result in some kind of a data loss, and that could have serious impacts on how the company performs. They could lose credibility with their customers. They could lose important customer data, which would mean that they can't reach out to the right kind of customers. So it could have a significant impact on an organization. So this is why it's super important to have storage to be, both redundant, so that even if one disk was to fail, that no data would really get lost, and so the data loss wouldn't really occur. And one of the best ways to actually prevent data loss is, using RAID, which is your redundant array of independent disks. Now, what happens is, in a RAID setup, the data is copied on multiple disks, so that in an event of a disk failure, no data would actually get lost. So there are really all sorts of different kinds of RAIDs, but we'll only be covering the four main in this session. So there's RAID 0, RAID 1, RAID 5, and RAID 10. So let's start with RAID 0, which is the stripping method. Now, it's not really a fault tolerant, because not only does it not provide any fault tolerance, it actually increases the chance of data loss. Because in a RAID 0, the data is not really duplicated, but it's actually spread, or you can say stripped, across these two separate disks. So even if just one of these disks were to fail, all the data will then get lost. So the only possible reason why you would want to use RAID 0 is for its immaculate speed, right? Because when you have two disk controllers working instead of one, then accessing data is that much more faster. So the next one that we have is RAID 1, and that is actually a fault tolerant method. It's the mirroring method. In RAID 1, the set of the data is copied on more than one disk. So you have disk 1 with the data, and then you have disk 2, which will have the exact same copy of the same data as you had on disk 1. So say if there was an event, you had a single disk failure, and there was a horrible tragedy, and disk 1, something happened to it, and you had the data loss from disk 1. But no data would then actually be lost, because you've got the entire copy of it on disk 2. So everything is then duplicated, so you still have it available. And this kind of a method is great, but as you can see, you're only utilizing half the storage that you could possibly be using, and these disks aren't exactly super cheap. So from an organizational perspective, if they had to do that with all of their data, that could prove to be rather expensive. Some other options that there are, and the most common one that we see most people using, most organizations relying on, is RAID 5. So with RAID 5, you need to have 3 or more disks, and it's fast, and you can store a large amount of data using the RAID 5 method. So what happens in a RAID 5 setup? Data is not really duplicated, but it's spread across multiple disks, right? And in addition to that data, there is another very important piece. So there's this information that's, once you have it evenly spread across all the disks, there's also this information called parity. And parity is used to then if if you were to lose the data, you use parity to then rebuild that data. So if there was a disk failure, you can use the parity data to then rebuild that kind of a data again. So the only downside that you'll experience with RAID 5, because since the equivalent of an entire disk is now being used to store parity data, it reduces the collective amount of data that you can actually store in all arrays. So for this example, if you have 4 of these disks with, say, 1 terabyte each, that's a total of 4 terabytes. But in a RAID 5 setup, the total amount that will be used for actual data storage will be 3 terabytes, because one equivalent of maybe 1 terabyte of information would be used to store all the parity information. And then the final one that we have is RAID 10. And RAID 10 basically, like the name says, is combining both RAID 1 and RAID 0 together. And you need to use minimum of 4 disks. So in this kind of a setup, you need a set of 2 disks that are mirrored using RAID 1 setup. And basically, then both setups of the 2 disks are stripped using RAID 0. So you'll have your 2 sets which are copied and mirrored, and you'll have your RAID 0 which is going to be stripped. So the benefits of this is, you get all the benefits from that you would imagine from a RAID 1 environment. So you're getting a complete mirrored image, so you're not losing any data. It'll be a win-win situation from that perspective. And from a RAID 0 perspective, you're getting all the speed, because the data is coming in and stripping really quickly, so you can still have all that speed. Now, the only downside of that is you can only use 50% of the capacity of the data storage. So if you're using 4 disks in this kind of a setup, you can only really use 2 of them for actual data storage. So economically, and in terms of how much data you can save, it just doesn't really make sense in how to go with this kind of a method or this kind of a setup in your environment. However, once again, this is very dependent on every organization. Every organization would have their own needs and their own data requirements. So whatever is best suited for them, they'll then evolve around that and use whatever kind of a RAID setup would fit in with their business needs. Now, a little into talking about these different kinds of storage, which is the 2 key ones, which are block level storage and file level storage. So let's start with block level. Now, this kind of storage is actually located close to the server itself in the same data center, and it organizes data in separate volumes. You can access them so every few servers simultaneously, so you can have them running separate volumes in separate servers, and you can access them all simultaneously, so there's not going to be any loss of data in terms of how you access them. And the second option is then your file-based storage. So this can be accessed by servers as well as other types of clients such as PCs, and data is usually organized in a hierarchy of files and directories. And because of there's an additional file system and there's network layers in between, performance figures are usually not as consistent as you would imagine with a block storage, which is directly linked to the server itself. So you can imagine the performance in block level being much greater than how you would expect with a file level, with this added addition agent of file level data. So when it comes to business data storage systems, the major options are your direct attached storage, which is your DAS. You've got network attached storage, which is NAS, and you've got storage area network, which is SAN. Now, direct attached storage is fairly basic. Like it's we use it. It's low maintenance. It's a low cost solution where the storage system is essentially part of the actual host computer or connected directly to the computer. So all of us have direct storage. So we're all using directly attached storage. And this could be pretty much as simple as an external hard drive. So if when it comes to DAS, it uses in many IT infrastructures, you'll see many people using direct attached storage. And in much larger organizations, you'll have much larger DAS storage units, right? And those can actually accommodate multiple disks. Now, that being said, for some business applications, you require a lot greater flexibility, which DAS is not able to provide, because it's a physical storage, and if you need to extend it, if you need to grow it, and you need to scale it, you're quite limited in how quickly and how efficiently you can do that. So then we move on to this idea of network attached storage. With network attached storage, what it offers is it's a dedicated file serving and sharing through a network, right? So it increases that significant amount of performance and that reliability with features, obviously, like we've discussed, like RAID and swappable drives designed for multiple higher multi-drive workloads. But what you get with NAS storage is, it's also a good solution for really consolidating storage systems from DAS. What you actually get with NAS, you get this one centralized shared storage system, which will essentially save you quite a lot of money in the long run. So it eliminates that confusion of where the storage is attached, which server the storage is attached to, as you would imagine with the DAS option. And essentially, it increases that reliability aspect of it, because in case of a system failure or there was an outage, you could easily, because it's all centrally managed, you can easily dedicate different storage for the servers. And for most small businesses, they usually tend to go with network attached storage as their storage of choice. Then we move on to storage area network. Now, this is a dedicated high performance storage system, right? And what this does is that it transfers block level data between servers and storage devices. Now, SAN is typically used in data centers, which is why we will go on to talking about our virtual SAN as well as we go along. But ideally, SAN is your typical component that would be used in a data center, and enterprises would much rather rely on having SAN storage, purely because it provides that flexibility and that reliability of NAS. And also with SAN, what you get is the quick speed that you would expect with direct attached storage. So essentially, it gives you best of both worlds, right? So it's usually the very sophisticated option that's sort of meant to really help solve all those mission critical application needs. It could be, as organizations grow and enterprises grow, they have significant needs and a lot of pressure on how they would use storage. So from that perspective, SAN is as the choice of storage. So how is storage actually allocated, right? How do we provision storage? Now, thick provisioning is the traditional model of storage provisioning. And what you get with thick provisioning is, so what happens is that a large amount of storage space is provided in advance, much in advance, all in anticipation of how much future storage that you'll be using. So, before you set up a virtual machine, you assume to yourself how much storage a particular server or a virtual machine will utilize, and then you allocate that kind of a space. And once you've allocated that space, no other virtual machine or servers could then access that particular storage. So how much space you allocate is how much space that will be occupied in that disk, right? Even if that space is being unused, so even if the server is not utilizing all that space, because you've allocated it, that's now being dedicated to that particular server. And this can actually cause a lot of underutilization of storage capacity, right? Because we never know how much storage we're actually going to use. So we always try to go up and beyond. So say, I'm going to dedicate 20 gig when you only know you're going to need 10, but you're going to dedicate 20 just in case. But that just in case and that extra amount of storage is now being underutilized. And when we think of it in bigger terms, when we think of it from an organizational perspective, that could be a lot. That could cost significantly a significant amount of money for organizations. So now let's talk about hypervisors, right? And before I sort of mention more into what virtualization is, and I know I've mentioned a few words here and there, but let's talk about, this idea of hypervisor first. Now, essentially, a hypervisor is a software layer that really coordinates all your virtual machines. So you can think of it much like, a piece that serves as an interface between the virtual machines and the underlying physical hardware. And what it really does is it really ensures that all the virtual machines sort of don't interfere with one another by using, any of each other's resources or memory spaces or compute resources, right? You can think of a hypervisor as much of a traffic police, if you could say, that would really control the flow of traffic, right? So it manages what's coming through, what's going through at the intersection. Hypervisors is much like that. If you think about it, it acts a lot like, it makes sure that each virtual machine gets the resources it needs and in an orderly manner. Like, so, if a particular virtual machine requires particular resources, then it gets those resources in an orderly manner. And there are two key types of hypervisors. So you have type 1, which is your bare metal hypervisor. This interacts with the underlying physical resources and essentially replaces the traditional operating system altogether. And in most data centers and in most virtual server scenarios, this is the most common used hypervisor. So it's the bare metal hypervisor that you would use. And it is the hypervisor that we'll be referring to when I'm referring to hypervisor. This is the hypervisor I'll be referring to as we go along. But there is another type of hypervisor, which is a hosted hypervisor that runs as an application on an existing operating system. And these are most commonly used on endpoint devices to, run an alternative operating system. So say you have a Dell laptop, you can actually have both Windows and Mac OS running on it at the same time, because it partitions the hard drive, so you can have two OSs running on one device at the exact same time, which is pretty cool. But yeah, that these are your two different types of hypervisors that you'll see. And I've mentioned VMs or virtual machines a number of times. So what really are they, right?
Sorry to interrupt, Simran. We have a question in the Q&A session.
Oh,
I think it's related to the previous topic. It says, how is that related to block level storage? I am more familiar with file system based direct storage.
If it's okay, shall I take the questions right at the end, because I might be covering it in the storage section of the presentation, so you might get the answer there. Is that okay?
Sounds good.
Perfect. So, sorry, there we go. Yeah. So, and I'll touch on that as we go along when I go onto the storage section, so you might get your answer there, and it'll just make a bit more sense. So we've mentioned virtual machines a number of times now already, but I just wanted to sort of go over what they really are. So we know that hypervisors sort of host virtual machines, right? So they're called the hosts. What these virtual machines are then, because they reside on these hosts, so these are then called the guests. And to the end user, to you and me, a virtual machine isn't any different to a physical machine, like like our laptop. So, it has a CPU, it has a memory, it has a disk to store our files in, and can connect to the internet as and when needed, right? But what's different with a particular physical machine is obviously, you can touch it. It's there, it's tangible, it's a thing. But with a virtual machine, it only exists as a code and a software defined computer that is running on top of a hypervisor that we just spoke about. And a hypervisor really separates the machine's resources from a hardware, right? And really provisions them appropriately so they can be used by different virtual machines. So any physical machine with the hypervisor would then be called as a host, right? So a hypervisor, what it does, it really treats all these compute resources like a CPU, like memory, storage, as a pool of resources. So from a hypervisor perspective, everything underneath the hypervisor in a physical hardware is now become a pool of resources. What it sees is it now has a bunch of different resources that it can allocate to any of the virtual machines that would sit on top of it. It would, in a way, if you could think about it, like I said, with a traffic controller, because it can understand and it's at the intersection of it, it can allocate resources very conveniently into all these virtual machines and keep them completely isolated from one another, which is very important because you'll have multiple virtual machines running on a single piece of hardware, but you don't want them to be interfering with one another. So essentially what this hypervisor does is that it's clever enough to just sort of understand, you know, every virtual machine has its own resources and it sticks to that, and it sort of encompasses it within itself and doesn't allow them to interfere with one another's resources. And when the hypervisor has the capability of understanding what kind of resources are required by a particular virtual machine. So now we'll go on to talking about just a virtual data center, right? Like we've spoken about data centers, and they're really, you know, what organizations need them, and they have big data centers, as we've seen. We've spoken about virtualization and, you know, how it's creating so much efficiency around for people. But what about virtual data centers then? So there's obviously lots of benefits of having a virtual data center, or you know, having a data center virtualization, as we would call it. Firstly, you know, you'll have increased efficiency in multitasking, because you can now run, like we've just said, multiple computers instead of just one single computer. You can run not just computers, but you can run multiple operating systems on a single set of hardware. So essentially, you're really increasing the efficiency because you're allowing this one piece of device to multitask. As well as that, you can get increased availability, because with the availability of what you're getting is you get the ability to screenshot your virtual machines, you get the ability to clone these virtual machines, as well as, you know, have redundant virtual machines. All this can actually allow higher availability of applications for the end user, essentially increasing organizations need to have their applications be available at all time. It can also, you know, from a virtual data center perspective, it allows for less labor to be involved in needing to monitor the data center at all times, because traditionally you needed an IT technician to be on site at all times, because you just never know when a data center would go down and you need someone to be there at hand. But because now most of the complexity is now in a form of a software, now you don't need manual labor to be monitoring and looking after physical data centers, because all of that can now be managed through a software, right? So, you know, that really increases the amount of manageability you can get out of a virtualized environment, because, you know, it gives you that better control, it gives you that better visibility of your entire data center as in a form of software. Because essentially, if you think about it, you can store a lot of files in your storage components. You know, you can have drawers full of files, but those same files in a digital format on your computer makes it so much more easier to then look for stuff, because you can easily search for things, you can have it all visible in front of you. So just to put it into comparison how easy manageability becomes when it's all virtualized, through this idea of having your data center being completely virtualized. There's increased sustainability, right? Because you get this increased amount of energy saving through being able to consolidate the amount of hardware that you're using, because essentially virtualization is allowing you to use less computer hardware, right? So if you're using less computer hardware, you're using less electricity, essentially helping, you know, with sustainability and with the environment as well. So it's really good for the environment, because amount of energy that it requires to run data centers, or not just to run the data centers but then on top of it to cool those data centers, it could be significant. And as you see there, software-defined data center, essentially what it is, by having an entire data center in software, by having it all virtual, these benefits are then extended across the entire data center and not limited to just the compute resources, right? So if we can do something, all this amazing stuff on the hypervisor level, which we said, when, from the compute side of things, if an entire data center is then now completely software defined, imagine all the cool stuff. Imagine all the crazy things that you can now do once you have everything in a virtualized platform, because you can things would be a lot more flexible. They would be a lot more easy to move around. They will be more portable. So when things are in software, you can add more policies around it, you can add more programs around it. So it makes just more sense to have everything virtualized. So we've spoken a little about server virtualization. So the first component when it comes to a software-defined data center is essentially, that compute layer, the server virtualization. So I have a quick analogy just to sort of sum up everything that we've spoken about just now. So imagine you own a hotel with a single giant suite, right? It's an amazing suite with plenty of room for just yourself. So there's one big massive room. It has all the facilities. It's really big. But the idea is that most of the space in that massive room really goes unused, right? Because there's only one of you. And even when you go out to renting it, usually there's only maybe one person out there who really wants to get this place. And it's really, extremely rare to find a big group of say like 10 people to rent a place and, fully use up all the available space in that entire suite. So wouldn't it be much more efficient and profitable to split that building into smaller units, right? That each unit could then be used separately and more guests could stay at one time. Now, physical servers that don't use virtualization are pretty much like that, right? They're pretty much like this wasteful hotel, because they run a single application that uses 30% of the resources, and all of the rest of the resources are just sitting idle for majority of the time. And it's really rare that you'll find an application to use all of the server's computing power and all of its resources. So as we see in our hotel example, we fix the problem by dividing the hotel into many smaller rooms, right? How do we do that with physical servers? Well, like we just spoke about now, we did that with 20 years ago with virtualization. It's much like dividing the hotel room into smaller rooms. Virtualization actually, allows you to assign all the available resources into, including your processing, including memory and storage, all these into individual virtual machines. So you can then run multiple virtual machines on one server. And each of these virtual machines are able to then host their own operating system and application. So much like the hotel, with virtualization, you're actually able to increase efficiency of those physical servers. And what we then did, if you think about it from a data center perspective, you then need obviously the storage aspect of it as well. So a software-defined data center, the three components are your compute, storage, and network. So if we've virtualized compute side of it, what about the storage? Now, storage can also be virtualized by consolidating, your multiple physical storage devices to appear as a single storage device. And how it does that is that it separates the storage management software from the underlying hardware, right? Much like it did with the compute as well. So it's sort of separates that software from the underlying hardware infrastructure in order to really provide more flexibility and that scalability that you need in order to provide resources to all the virtual machines. So what it does, it combines all the resources and creates a scalable pool of resource, and this is primarily focused on storage itself. So what you get is that an ESXi provides that with VMware ESXi, what you get is a host level storage virtualization, right? Which logically then abstracts the physical storage layer from all the virtual machines. So a virtual machine uses a virtual disk to store its operating system, its program files, and all the other data associated with its activities, right? And a virtual disk is a large physical file, or or set of files that can then be copied, moved, and archived. You can back these up. You can easily move them to another host. So you can configure virtual machines with multiple virtual disks. So if you think about it from a virtual perspective, having a virtual disk attached to any virtual machine, you're not relying on physical storage as such. So there's no dedicated storage that you would have to use for a particular virtual machine, or a particular workload on that particular server. And each virtual disk that resides on a data store that is deployed on a physical storage, from a virtual machine standpoint, each virtual disk appears as if it was a SCSI drive connected to a SCSI controller. You don't, from a virtual machine perspective, if you're if I'm the virtual machine, it doesn't make a difference to me, because it's the exact same thing that you see. Whether the actual physical storage is being accessed through storage, or whether it's being accessed through network adapters on the host, it's typically, for most of the times, transparent to the operating system itself, and to then any applications that are running on that particular virtual machine. So if you think of it from that example, or from that perspective, everything underneath, you've pulled all the storage together, you've pulled all the resources together, but the virtual machines and the applications that are running on top of it don't see any difference. So there's no compromise in the performance that they're going to achieve, and there's no compromise in how they're going to be um, 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 processing any of the storage resources, because to a virtual machine, it's like they were connected to a SCSI drive, right? And from a benefit perspective, if you think about it, there's loads, right? You get performance, you get a lot of speed, and you get load balancing out of it, because once again, like we said with virtual compute, with virtual storage, you can then easily move storage around because it's all part of the one same pool. You've got a hypervisor which is cleverly sitting in between, allocating like a cop. They can sort of um, understand which traffic goes where. So with that clever little software sitting in between, you can actually help load balance quite easily, and you can also reduce cost, right? Because if you think about it, storage virtualization kind of helps with that disaster recovery planning, right? So you don't need to have a separate virtual storage data that for storing your data, because you can easily duplicate your data and quickly transfer it to another location. So essentially, you're helping with the disaster recovery. So if one server was to go down, or if one storage disk was to fail, you can easily quickly replicate that onto another and have it up and running. So essentially, you're reducing any downtime that an end user would then be facing. And then we have network virtualization, which is obviously the third component of a software-defined data center. Network virtualization makes it possible to really create and provision and manage all your entire network, but in software. So once a software-based view of the network has actually been created, the underlying hardware is generally only just responsible for really forwarding packets, while the virtual network, which is the clever piece that's sitting on top, it's doing all that clever stuff, like deploying and managing the network. It's understanding the policies. It's making sure the policies are related to the particular virtual machine. So every virtual machine would have its own network policies attached to it, right? And because this is all in software, it's a lot more flexible. So when a virtual machine is moved to another host, all the networking and security policies that are attached with it will also move to another host. In a traditional manner, when you're trying to move a particular virtual machine from one host to another, you have to do the back-end work of changing the network, changing the MAC addresses, having to change the where the target host is compared to where the start host was. So you have to change all of those components when you're moving a virtual machine. But in a virtualized world, where if the network is virtualized too, all those policies that are attached to the virtual machine would then go along with it. So say if you were to create a new virtual machine, you can easily do that. You can easily scale an application. So say if there is a new virtual machine that was required in a particular application, you can create that virtual machine, and all the necessary policies that you've previously associated with that particular application are then sort of dynamically applied to the new virtual machine that you just created. Since, all the network virtualization, all of that is automated anyway, that configuration that usually used to take quite a bit of time and takes a lot of manual processes has just been reduced. So it saves a lot of time, it saves a lot of risk, because there could be a lot of manual errors that could come along in the way, but it saves a lot of that. And common terminologies that you'll see when we're talking about network virtualization is, you got your virtual switches, which are pretty, they're cool at, directing packages at the right location. So you have a virtual switch, which is essentially a software program that really allows one virtual machine to communicate with another, and it's quite intelligent in a way. It directs communication on the network, right, by sort of really inspecting the packets before it's passing them on. So the virtual switch will sit in the middle before it allows the packages to go through. Then you have your virtual local area network, right? And that's your logically independent network. It's segmented into different groups of ports isolated from one another, which essentially, basically what it does, it allows you to create different network segments. And you can have several VLANs existing in a single physical switch, right? And what network virtualization really does is it really allows those network challenges that we face today in the ever so fast our data center lives that we're living in today. It's really helping organizations to become more centralized and be able to provision network on demand without having to even physically touch the underlying infrastructure, which is quite daunting for organizations, because you don't want to mess about with the network. So essentially what it really does, it can really simplify how you manage your network, and roll out these new networks and new virtual machines quickly. So if you have an application that's ready to go, but you're stuck because of the you haven't provisioned the network, by having it all virtualized, you can quickly set this up without having to rely on the physical infrastructure itself. So essentially it really helps with meeting all those evolving computer needs that we see today.
Simran, there is a question in the chat that says if you can virtualize the storage as well.
Sorry, can you repeat that?
Yes, if we can virtualize the storage as well.
Yes, we can. So and I'll go into talking about how we're virtualizing storage, but yes, we can. What we've done is we've virtualized compute, which the hypervisor has, when we spoke about with our components of vSphere. But what we've done now is we've virtualized storage, and we've virtualized network as well. So when we talk about a software-defined data center, that's basically all virtualized data center, which would include your storage, compute, and network. But I'll go a little bit more into it as we go as well. So let's quickly touch on what the cloud is before I start talking to you about VMware solutions. We have a lot of on-premises IT infrastructure, right? I mean, it's great. Most organizations have they have their own data centers that they're running in their own on-premise, and it's fine. But the issue is, every time you want to expand or scale, by having everything on premises and having your own data center basically means putting in a lot of capital expenditure upfront, because you'd be investing in really expensive racks in terms of storage, in terms of compute. And these pieces of computers, these pieces of hardware aren't exactly cheap to purchase, right? So this is why people are moving more and more towards this idea of cloud. Now, cloud computing, what it does is it basically provides computing over the internet, right? So it provides all of those hardware components over internet. A cloud computing service essentially consists of a highly optimized virtual data center, and all that it provides is all sorts of, all those various softwares that you get, all the hardware that you get, that you expect from an organization. It can now deliver that through cloud. And if we were to put it very simply, what really is that cloud does, it essentially is this shared pool of resources that you have, which is giving organizations access to anything that they need. So if an organization needs some sort of compute resources, they can go to cloud and have and collect some, use some, and pay as they go. So it's not something that they need to pay upfront for. They can pay amount that they use, and then when they're done using it, they can stop paying for it, and they wouldn't have access to those resources. So it's pretty much moving away from having to spend something upfront to having to be able to expand and scale as you grow. Now, like I said, this is obviously very seriously helped organizations from the capital expenditure perspective, from getting resources, but it's also helped them scale really quickly as well, because they can scale out and back in really quickly without having to rely on serious expenditure. And from a cloud data center perspective, right, you can have multiple data centers made up of compute, you can have storage, you can have resources connected by a network. But what really makes data center a cloud, it's all that the resources inside this particular cloud are all virtualized, because it's a big giant shared, we could think about it, it's a pool of resources, a giant shared pool of resources, right? And ideally, they can be really intelligent in how they allocate these resources to organizations. And I'll go into talking about the different types of management that an organization can provide through cloud. So essentially, we have, So essentially, we have three types of cloud computing, right? So we have something called software as a service, which is, as you see on the top. And these are essentially for our customers, okay? So the idea is that you have a completed product that is ready to run and, and managed by a service provider. So you don't have to worry about any of the maintenance, anything. It just works, and, you just throw and use and consume the services, right? So an example of a SaaS service would be your Gmail or Office 365 or Salesforce. These are software as a service. What they're doing is essentially you're just using the software as you go. So these are mostly used by consumers. Then if we go down to platform as a service, right? This is really then intended for developers. It really removes the need for an organization to manage the the underlying infrastructure, and more focus on the development and management of their own applications, right? So the idea with platform as a service is you don't have to worry about provisioning or really configuring the underlying hardware. It just works, right? So if you push an app, so for AWS, you have Elastic Beanstalk, you've got Amazon Web Services and S3, you've got Engine for Google. So essentially, you could just push out an app and it would work. So the rest of it is managed by the managed services. And then the last one on the list here is the infrastructure service, infrastructure as a service. Now, with this, you're really intended, it's actually aimed and intended for admins, right? So when you're really using, say, AWS, or you're using Google Cloud Platform, or you're using Azure, this is what infrastructure service is. So it's basically that basic building block for your cloud IT, right? So it provides access to the network, all the features, and all the computer data storage, but you don't have to worry about it. You don't have to manage that. So essentially, an organization wouldn't have to worry about the IT staff, any of the data center, any of the hardware. All of that is managed by the service provider. So just to put it out for you and what it would look like, if everything was on premises and an organization was looking after its own data center, this is what they'll be looking after, and this is what's going to be their responsibilities. This is what an organization would have to manage from start to finish. They'll be looking after everything. In infrastructure as a service, they get the network storage and server virtualization managed. So all they do is from an OS perspective above. So everything from an operating system onwards is what they'll manage from an organization perspective. So they'll look after the applications, they'll look after the operating system. They can create a platform for their own customers, but they don't have to worry about any of the underlying hardware or any of the underlying infrastructure. With platform as a service, it takes a step ahead. So they don't even have to worry about what operating system they're running on. They just push out applications and the data, and it would just, the rest would be managed by the service provider. And then you have your software as a service, which, like I said, it's ready to go. You've got an application that's just ready to consume. You're just pushing out codes as such. So essentially with cloud, you have three key deployment models. So you have your private cloud, and as obviously the name suggests, a private cloud is private because, you know, there's only one tenant in there. So the organization gets all the goodness of the cloud. You know, you can control it, you can customize it and fit it to your own needs. And because, you know, you've got so much control over it, which is why, you know, now we see so many companies are migrating towards this, you know, their data centers towards a private cloud, because they want the flexibility and the speed of a cloud, and they also want to be able to have a control as they would have on their own premises. So private cloud is quite ideal, and it's attracting a lot of organizations at this very moment in time. Then on the other side, you have public cloud, right? What we have with public cloud is essentially, as the name suggests as well, it's hosted by a cloud service provider. So, you know, you can have AWS, you can have Google Cloud, you've got Azure, you've got Alibaba. There's plenty of cloud providers that are hosting these cloud services, right? So what they do is they rent out a space on the cloud, and many of their customers, or tenants as you would call them, pay for the service that they use. So they allocate them a significant amount from their data center, and the tenants would use and consume as and what they need. If you think about it, it's much like how we use electricity, right? We don't need to pay for the electricity up front. We use however much we need, and we've got electricity provider who provides us with that kind of electricity or gas, and we don't need to worry about how much we need to pay in upfront. So all we pay for is how much we use. Public clouds work much like that. Everything else is managed by a third party, but an organization only pays for what they use and when they use it. And then, of course, you have the hybrid world, right, which is the best of both worlds. And as the name again suggests, it's a combination of both the public and the private cloud. So you get all the benefits of the both, and actually more, because you know, you have the ability to create all the new kind of applications, you know, innovative applications. You can create them now, and you can host them in your private cloud. And you can also, you know, if the demand spikes up, you can burst into the public cloud as and when needed, and then bring the workload back when it's not so busy. So essentially, you know, with the hybrid cloud, you get the flexibility to be more scalable and be more available as your organization has for needs and demands. So this basically sums up of what the market is going on in terms of virtualization and what the cloud is. So I'll now walk you through just some of the concepts of where VMware solution fits into all of this and how VMware came into play. So I'll start with vSphere, which is a product that we obviously launched over 20 years ago now, and you know, it was the market leader, and it's what really gave VMware that name, right? So it's what made us the market leader. It's vSphere, and essentially, you know, vSphere is what really made virtual data center possible, and there's a reason why it's a market leader in virtualization platform, right? So as you see in this particular diagram, we have a data center and it's been virtualized, and there are three main components as you see here. So, you know, you have your vCenter server that manages all the virtualization. then you have your actual virtualization servers. So these are your ESXi hosts. These are all bare metal. So these are the type 1 bare metal virtualization servers that we spoke about. You then have your, your virtual machines or your virtual computers that are running on top of them. And then you have your storage, which is obviously there's a storage which is you've got network attached storage, or you can have your SAN, where you can have all your files and data saved, and it's saved so that one of these servers can actually access this data over the network. So you have your server serving your virtual machine, and you also have your management server that can then manage all these servers. And it's it's important because it builds inside the scalability, and when we talk about fault tolerance and we talk about redundancy. So for example, we can actually migrate virtual machine from one server to another if a server fails, right? And I'll go into that a little bit later on as well. But essentially, it gives you that the dynamicness of being able to move your environment from a failover. So it doesn't have to be something that's a make or break kind of an environment. So if something was to fail, you could easily move your virtual machines and the data that goes along with it to another host. And same goes for the storage as well. So if we take a quick closer look of what we really mean by ESXi. So here you can see a physical server at the bottom, right? So these are all your physical servers. So the physical hardware is not going anywhere. You just don't need that much of it because all the cool stuff is now happening in the software layer. So an ESXi server installed on them really makes that then the type 1, the bare metal hypervisor, right? So this basically means it's the operating system that's on these servers is the virtualization server operating system, right? So that means the virtual machines can now be created on this particular ESXi server. So as you can see here, it's that you've got your 5 virtual machines on each server that's running on it, and virtual machines will be primarily used to actually be what you'll use to provide an application, right? Or a software. So you'll be using your virtual machines as a basis of that. And other than that, you'll probably have an entire operating system, an entire OS that you could probably access from an ESXi server. But essentially, if you have one too many of these, so right now you have 3, but if you were to have more than that, how would you then go about managing all these different virtual machines? And for that, we have something called vCenter. They're all separately managed through a separate server called, obviously, a vCenter. And what it really does is it does this a really cool job of actually being able to manage all your virtual machines. And if your virtual machines are sitting on one ESXi server and you were to move it to another in order to sort of load balance or manage your load from say one host had too many virtual machines and the other didn't have any, you can easily load balance that, and vCenter is then being able to clever enough to manage that for you and do that. So how would you essentially access your vCenter server, right? Well, the vCenter server is essentially accessed through a web browser, and it's called a web client, or you can use a vSphere web client that's used to manage the entire virtual data center. When organizations have a lot more virtual machines, they can have another management tool on top. But many of our customers are very happy with vCenter because it provides them with that management console that they need in order to manage all those virtual machines that they have. So what you do is you simply log in through a web browser into your vCenter management console, and then you use you've got a nice little graphical user interface which allows you to you've got your icons, you've got your menus, it's got all the settings that you need to either turn off or on your virtual machines. You can delete them, you can create your virtual machines from that interface, you can add storage to it, you can set up a network, you name it. You can do a lot of stuff just from having this particular interface in place. So you don't have to be dealing with a terminal based kind of interface, right? You don't have to be looking at command line instructions to be able to generate a virtual machine. This is all done through a web client, so you can actually have a decent interface which can allow you to create a virtual machine or add storage to that particular virtual machine. So a lot of cool things that you can do through vCenter itself. Then we have something called a snapshot, which is basically a copy of a virtual machine. What a snapshot does, pretty much like, we have it on our phones as well. A snapshot is a copy of a particular virtual machine at any given time, right? It provides kind of like a change of log of a virtual disk, which can be used to then say if your virtual machine, if you're changing something in your virtual machine and something was to go wrong, you can go back to that particular point in time and case. So in a way, it actually helps with any system failure if it was to occur. You actually can take multiple snapshots of a virtual machine to create multiple possible point in time restore points, which, say if you were testing something on a particular virtual machine, or you're changing something about it quite significantly and quite frequently, you can create multiple snapshots so you can easily go back. But an important thing to remember here is the fact that when a virtual machine goes back to a particular snapshot point, then everything that you've done after that, you then can't access. So then the current disk and the memory states are then particularly, deleted from that point onwards. So that snapshot then becomes the new parent snapshot, as you could call it, because essentially everything that then happened afterwards just does not exist in that environment. So usually, you would use it as a point of recovery point. You can use it as a restore point, but it's not ideally recommended or referred to as a backup point, because you see some organizations wondering why we can't just use snapshots for remembering the state of our environment and using it as a backup. It's because it's not a really good, decent backup solution, and you have your other backup solutions and you should have them. Snapshot is just a way of going back into a restore point of time of a particular virtual machine. Another really cool feature of vSphere is vMotion, right? By vMotion, you can actually move a particular virtual machine from one host to another. And when you're moving that, you're simply changing the host that is running that's running that particular virtual machine. And you do a live migration. And when I say live migration, you're basically moving a virtual machine from, say, one physical server to another, but the virtual machine itself doesn't really realize that the changes happen. So the user, the end user, has no downtime. They don't come across any changes. They don't see anything different. They just use it as they would use the virtual machine from a front end. But this all happens in the background. So it's really cool when it comes to live migration from vMotion perspective. Our CEO actually did that on one of our events in VMworld, where he vMotioned an entire application from on-premise to cloud, and he did it live in front of everyone, and it was just quite astonishing how you can literally pick up a file and then move it to a complete different location. But the only difference is it's not just a file, it's an entire virtual machine, which could be holding an entire application per se. But to move it from one location to another is as simple as moving a file from one folder to the other on your laptop. And that's how easy vMotion has made it. And essentially what it does, it increases the availability of the data and the resources that are available to the user. And because the move is so completely transparent, what it allows you to do is that you can get that continuous service and that availability, because from an end user perspective, like I said, you're going to not face any downtime as such. A similar thing we can do with storage vMotion as well. It's a component of a VMware vSphere, and allows the migration of the storage files. So not just the virtual machine itself, but the virtual machine files from, say, one storage location to another. And this is all while the virtual machine is still powered on. So once again, you don't get any downtime. Storage vMotion is actually a complete process of an entire virtual machine migration. So you're not only moving the computer and the memory like you do with vMotion, but you'll be transferring the entire disks as well. So essentially moving the entire thing to an entire virtual machine footprint to another storage device. another cool feature of vSphere as well is now we have VMware high availability. Why this is so cool and why it's super essential for customers is that it allows companies to, provide that high availability to any applications running in their virtual environment, right? What HA does, it detects any server failure and initiates this virtual machine restart without really having any human interaction or any intervention from a human perspective. So the way it works is that it's got an agent placed on pretty much every server. So if you've got HA enabled on the particular server, then you'll have an agent placed on that particular server. And every server then maintains a heartbeat, right? And it maintains that heartbeat with all the other servers in the resource pool as well. So if it's in a cluster, every server in that cluster would have a heartbeat, and they all would be communicating with one another. So as soon as HA notices there's a loss of a particular heartbeat, that's when it initiates a restart process, and it allows for another virtual machine to be created elsewhere. So it quickly recognizes a particular host has died, or something's happened, or it's failed, and it quickly moves all the virtual machines to other hosts that are still active and working. Then you have distributed resource scheduler. And now this is a clever little feature, right? That allows sort of virtual machines to automatically balance themselves across ESXi hosts, and in particularly within a cluster. So ideally, the main goal for a DRS is essentially to basically be able to place each virtual machine. So when it starts up, each virtual machine should be placed in a best suited location that can run that particular virtual machine. So, if a virtual machine has a requirement of a certain amount of memory, it needs a certain amount of compute resources, DRS would make that decision of where to start it up on which host, because it has the visibility of understanding what hosts are running what, and in terms of priority, in terms of understanding the availability of resources, it would then start up that particular virtual machine according to those. And essentially, if a DRS becomes unbalanced, if for one reason you have too many virtual machines on a particular host and not on the other, it's DRS's job to then migrate any virtual machines from, say, an overutilized ESXi host to then an underutilized one. And while it's doing all these migrations, it's doing them completely live using vMotion, like we just discussed, right? So while it's doing all of this, to the end user, they don't realize anything, and so there's zero downtime. From an end user perspective, I don't see the fact that DRS is doing all these cool things in the back end, because what it's essentially trying to do is provide me with, as an end user, with the best performance for my virtual machine. And essentially, you could do the same for storage DRS as well, which would do the same thing with from a storage perspective. So allocates and balances out the storage distribution. And then we have fault tolerance, and essentially a fault tolerance provides that, the continuous availability for applications. What it really does, it creates like a shadow instance of a particular virtual machine, right? That would really mirror the primary virtual machine. So say if there was a hardware outage or something was to go wrong with a particular server, what vSphere fault tolerance would do, or vSphere FT would do, is it automatically triggers a failover to sort of eliminate the downtime, and it really then essentially allows there to be no data loss. So it quickly understands that there's been a failover. So it would there's been a B server, there's been a server that's been completely failed. So it would completely trigger the failover effect and restart those virtual machines on separate servers. And a point to note here is, after the failover has happened, vSphere actually then automatically then and once again creates a secondary virtual machine, right? Which is then again a shadow of that original one, because the original has died, so it's created a new one, which is a shadow image, so that starts up. But once the original has actually gone out of sight and it's failed over, the vSphere FT automatically then creates this new secondary virtual machine to deliver that continuous protection alongside of the application. So there's at no point do you actually have to face a complete failover of a machine.
Simran, there is
Yeah,
another question.
yeah.
If you could please clarify host versus server.
Sure. So a host and a server are exactly the same thing. The reason we call a host a server is because the servers are essentially hosting those virtual machines, which is why you can people you tend to call them hosts. So, but there's no difference as such between them. A host and a server are two exactly the same things. So we've spoken about vSphere, which is obviously consolidating compute resources and sort of pushing them as a pool of resources. vSAN essentially is pretty much exactly that. What we do is we pool the resources from a storage perspective and bring it to and present it as just one to the virtual machines that are on top. And because vSAN is part of the hypervisor itself, so when we spoke about hypervisor, which obviously included vSphere, now vSAN actually is part of the hypervisor too. So when a customer is buying a vSphere, an actual device which had, and they if they're buying a rack of, and from Dell, and they're buying an x86 server and they're installing vSphere, it would come with vSAN as well. Now they wouldn't be able to use it because it'll be the licensing issues, which is completely separate. But from a technical perspective, it'll have all the functionalities in it, and because vSAN is now embedded within the hypervisor itself, which is, if you think about it from an I/O perspective, it's really cool because you'll have some other solutions which have a similar virtualized storage network, storage area network, but what they do is that they include an agent on the virtual machine. So an agent has to speak to the virtual machine before it allocates to the storage. But because vSAN is embedded within the hypervisor itself, it reduces that time for the I/O to communicate between one another. So if you think about it from that perspective, you're really allowing the organizations and customers to get the best of their storage and compute needs at once, because it's all embedded within the one hypervisor, which we call a hyperconverged infrastructure. And because it's embedded within the hypervisor, it can interact with vSphere really closely, and it could actually then create from a management perspective, you're using the exact same tools that you're using to manage vSphere, you now would be using to manage vSAN as well. So from a management perspective, you're easing a lot of stress from an organization perspective.
We have another question
Sure.
here in the chat. What is the difference between fault tolerance and high availability? And if it is right that the secondary VM in fault tolerance is up even before primary VM goes down.
So with okay, here we are. So with high availability, it's based on moving all the virtual machines to different servers, right? So you're not, it's basically dependent on the server itself and on the heartbeat of the server. So it's not really focusing on the current state of the actual virtual machine. So it's just moving all the virtual machines from one particular server to another in order to not have any downtime. So that's the primary goal from a high availability purpose. It's always available, always on. So you'll have the virtual machines available. But from a fault tolerance perspective, what it's doing, because when the fault tolerance is on, and this is the settings that you'll have high availability in any kind of an environment, you'll always have it available, and people would usually have it enabled in the environment. With fault tolerance, it's obviously a matter of you'll have the secondary copy, which is obviously taking up a lot of disk space and is taking up memory as well. So you can't do that with all your virtual machines. So essentially, you'll be doing that with your most mission critical virtual machines that will be in place. So you'll have that, which will have a secondary copy of it, which is like a shadow print of it. And it's not already running, it's just taking into account, it's basically taking snapshots of every state of that virtual machine as it goes. And it only restarts that particular virtual machine is when that particular virtual machine dies. So if a server fails here, and that particular virtual machine on top of it has then obviously not been able to survive that the death of that server, then it would restart that particular virtual machine on a new server. And it's doing that through fault tolerance purely because it's taken those images and it's taken those snapshots in order to quickly reboot that without any downtime, without any data loss, essentially. Does that answer your question?
Yes, thank you.
Then we have our NSX piece, which is our virtual networking piece, and this is again another component of our environment. So, like I spoke about software-defined networking, we provide that through NSX, and it creates that software layer of networking, which can then do a lot of cool things. So, one of the cool things that you can expect from an NSX perspective is it can do microsegmentation. Essentially, what it allows you to do is all these virtual machines in an environment are connected to one another in one way or the other, right? Because they're all in the same server, they're all in the same resource pool. Essentially, what NSX really does is adds that extra layer of security around it. So each virtual machine would have a firewall that's attached to it. Now, if you compare that to the physical world, most of the times you'll have a firewall that's only attached to the perimeter of your network, right? So you'll have really strong firewalls that will stop anything from entering your network, from your environment, from the outside world through the internet. Now, what we've seen in recent cases, in recent rise of cyber attacks and everything, what you see is if an attack does happen and it enters your environment, once it enters, it stays very idle for the next 6 months in order to fool the people, fool anyone who's it's trying to in the system, because that's just how clever the attacks have become now. So it'll enter the system, it'll enter the environment, but it'll stay idle for 6 months and then attack. Now, if it finds a way to surpass that perimeter firewall, then what happens is you're kind of exposing the entire environment to this virus now, because every virtual machine is connected to the other. So it attacks one, that could attack the other, and then it's an ongoing cycle, and all of the communication that happens internally within a data center can mean that that virus would spread really quickly. And what you can do with NSX and with microsegmentation, what it really does, it attaches this extra layer of firewall not just on the perimeter of your entire environment, but on each and every single virtual machine. So this is adding the extra piece of security. So now basically you're compartmentalizing all of your virtual machines into different compartments. So if an attack was to come along and it affected one virtual machine, you could quarantine that particular virtual machine, take out the resource pool, correct it, get rid of it as you would, and that would then not affect any of the rest of the virtual machines in the environment. So from a safety and security perspective, it's really helping organizations be more secure with their environment, because once again, if there's a data breach, or if there is a leak in the environment, or if there's a data leakage, this could actually mean from a brand perspective for organizations, quite significant. Like for most of our customers, it's their brand. They really value who they are, and they're very precious of their brand, and which is natural. And from that perspective, being on top of the game with security is one of the key areas that they're focused on right now. And NSX gives them that extra piece of security from a network perspective, just giving the added piece of security level that allows them to then be able to completely have their environment safe from any outside attacks or any threats. And essentially what we get is this VMware Cloud Foundation. So like I mentioned today, in terms of a software-defined data center, that includes your compute, your storage, and your network. But these are all three very different components, right? What you get with Cloud Foundation is you get a turnkey approach. What we speak to our customers about is, when we talk about Cloud Foundation with them, we talk to them saying, you get this entire completely ready private cloud that you can actually run on premises, right? So like I mentioned before, with private cloud, you get that, you get the safety of having your own environment, you get the speed, you get the security of the comfortness of knowing, and you can manage everything on your own. That's what they're getting with Cloud Foundation without the complexity that's added to it. So it's not managed by anyone else, they can manage it themselves. And essentially it's providing a package um, of vSphere, vSAN, and NSX all bundled together, but on top of that, they also get the management of it. So they'll get a VMware management portfolio that would sit on top of it. And along with that, they will get this an SDDC manager, which allows them to manage the upgrades and the patches of the software. So essentially what you're allowing your what we're saying for our customers to do now is, if they have a Cloud Foundation, they don't have to worry about having to buy different components, buy different storage requirements, by different storage resources or network resources. They can completely rely on something that's just ready to go and it works and it's proven. So everything to put everything together could be quite difficult. And I like to use the analogy of cakes. Usually when you're baking a cake, you obviously need all sorts of ingredients and you put them together, and usually you'll follow a recipe and you'll create a particular cake. And that's what traditionally we see most of our organizations doing. They would create their data center based on different components. They'll buy storage from one place, compute from another, network from another, and create their own data centers. Then you have something like, you can buy a box, which is everything is already pre-mixed, and you can just buy that box and create a cake from everything that's already pre-mixed in the ingredients. And that's something we get when we see our customers buying our server architecture. So they would validated design, so they will follow a validated design. They've got a complete design that they could follow, and they would create their own data center based on that. And then the third part of that would be, you could just go to a bakery and buy a cake, and that way you have it ready. You tell the baker exactly what you want, what you need, and they'll give you a cake. And essentially Cloud Foundation is that cake, right? It gives you, you get everything that you want and need without having to put all the effort into it. It's ready to go. And the beauty of Cloud Foundation is it's Cloud Foundation that we have running in our recent partnership with AWS. We've got a partnership with Azure. We've got it's with IBM. It's a Cloud Foundation that they're running on their bare metal in their own data centers. So when we speak to our customers and we tell them, if they wanted to run Cloud Foundation on their environment, it sounds more appealing to them because it's a trusted architecture that they see the large public clouds that are running in the world using. Because right now, the top three clouds that come to mind obviously are your AWS, it's GCP, and it's Azure. And all three of them are currently have Cloud Foundation running in their environment. So that's quite significant when we think about it from a perspective of how far we've reached in terms of from VMware perspective, and how easy we've made it for our customers to migrate from their on-premises environment to then to the cloud, and be able to use those cloud services as and when they need without having to be tied down to any particular cloud. Now, with that being said, and not being tied down to any cloud, you get this cloud automation center, which is basically your management portfolio that sits on top. So what we see with most of our customers, they wouldn't be all either on premise or they wouldn't be all on cloud. They'll have a quite of a mixed approach, where they'll have some of their environments running in the cloud, they'll have some running in on premises. So by having a management that sits on top of it, that can give them a full visibility of the entire environment, is quite appealing. And that's what cloud management can do for our customers. With cloud management platform, what they're getting is a complete visibility into all the environments, whether it's on physical hardware, whether it's on native AWS, whether it's on VMware. It doesn't matter, because what they're getting is complete visibility, and not just the access of visibility, but then they can maintain that environment as well. So if there were any health issues with the environment, or if it was coming across any risk, or how efficiently an environment's working, it's much like having a dashboard of a car That's what cloud management platform provides for our customers. It gives them full visibility to understanding what's really wrong, or what could go wrong in an environment, and gives them warnings or error signs, and essentially allows them to even be able to sort of understand what the environment in the cloud looks like. Another key thing that comes with cloud is obviously the cost that's involved with it. Most organizations would want to move to cloud because it sounds appealing, or the fact that they see most other organizations wanting to move to the cloud, so they feel that it's quite appealing purely because it's the next big thing. But there could be a lot of cost that's involved, that's kind of involved when it comes to moving to the cloud. And Cloud Health really helps with sort of analyzing cost benefits of moving to a particular cloud. So what you can actually expect from Cloud Health, it could basically analyze your entire environment of your cloud environment, and sort of give you suggestions of where it thinks you should be running your environment, whether it makes sense to have it run in AWS because of the cost savings, or whether you should run it on GCP, because bear in mind all of these places would have different costs associated with them. But Cloud Health can then actually help you understand, but not just from the cost perspective, it can actually help you from the governance side of things as well. It can help you understand where it makes where it's compliant to have your environment running, because you'll have different compliance issues in terms of where you can have where an organization can have their workloads running in Europe or in US. So from that perspective, it can monitor all of that and then give you a full visibility from that perspective as well, and essentially make that journey really easy for our customers, right? And if our customers are planning on moving to this idea of cloud, or want to move to the cloud, essentially we've got from a VMware perspective, giving them a full flexibility of whether or not they choose to go to the cloud or stay on premises. We can give them flexibility on how they want to approach that. And that basically sums up our VMware portfolio to significant level. Any questions at this point in time? So we have about 10 minutes. I think it's a good time to sort of take questions, and then I can talk to you about the next steps.
All right, so we have one question. It says, in case a company has two options to choose from, vSAN and NAS, which option would be better in terms of efficiency and price?
Between what, sorry? Can you repeat that again?
Between vSAN and NAS.
Between vSAN and NAS. So
yes.
For a comfort, and this is once again dependent on every organization, so it couldn't be a yes or no question, and we wouldn't go in and talk to the customer and say to them that you definitely need this. So it goes down to obviously analyzing a lot from a customer perspective. But the reason we go ahead and say a virtual SAN would probably be a better move for a customer is because virtual SAN is not just about providing them with the storage they need, but you can add all sorts of policies around it. So everything can then become automated without having to be worrying about how much storage a particular virtual machine would need, which is what you would have with shared storage from a NAS perspective. With virtual SAN, it's not just that you're giving them shared storage, you're actually giving them quite clever storage, because you have this policies that are attached to them, so they can make you can have deduplication around, you can have RAID settings in terms of how you want to move your data, in terms of how you want to store it and how you want to decouple it from the original parent data to the child data. So essentially it's giving customer a lot more flexibility in how they would like to use their storage needs. But once again, I would never go ahead and tell the customer you definitely need this over that, because it all comes down to their particular environment and what would be best suited for them. But from cost perspective and efficiency perspective, I would go with vSAN. So guys, you have a poll up there, which do go ahead and finalize that. But as part of your next steps, as you can see on here, you want to if you go to the link like I showed you earlier on as well, go ahead with the courses, try to do the hands-on labs, try to finish them as you go, and once you've completed that, you can actually get yourself a VMware badge, which is actually really cool, and it's industry-wide known. So you can have that as part of your own achievement, and you can include that on LinkedIn and just use it for other purposes as well in terms of it. But essentially, what do go through the course, because everything that I've gone through today, you can actually go into it in a lot more detail, but at the same time you can go through a hands-on lab, which would actually allow you to use anything that you've learned today into practice and put it all into actual use of what you're going to be doing. And there's also a YouTube channel which covers all the topics that we've sort of touched on today, but all other topics that I would bring up from a cloud perspective, from virtualization perspective, and so if you were to go to that link, are we sharing these links with them at any point?
Yeah, we do share these links. Yeah, I will attach this to Women Who Code.
Perfect.
GitLab.
So yeah, and I can, if you want, I can copy and paste that for you.
Thank you so much for this presentation. It was awesome. Personally, I learned so much, and I can't wait to for the next presentation. As we discussed, the next presentation will be on October 15th, right? And it will be about storage.
Yes. So the next one would be on storage, and the one following that would be then on networking. So before that, I would really recommend you completing your virtual labs for the compute virtualization, and then hopefully when we go on to the storage side, you can then move on to the next labs, and it would just put a lot into place. But I look forward to seeing all you guys in the next session, and thank you.
Thank you very much, Simran, and
thank you.
See you in the next session.
Perfect.
Nice
Thank you, guys.
Rest of your day. See you soon. Goodbye.
Take care, guys.
Bye.
Thank you. Great session.
Excellent. Thank you very much.
End our meeting. Now we'll see you lovely ladies in email.
Absolutely. See you.